It is jointly organized by RFI and World Innovators University, sponsored by JHEI. Eklavya University, research using SPSS. And for this, our today's expert is Dr. Chanchala Jain ma'am is with us. She is a really divine personality. But before we start our today's session, I would just like to introduce our today's expert, Dr. Chanchala ma'am. Dr. Chanchala Jain ma'am is an author, research expert, and academician with an experience of more than 11 years in management and commerce as an assistant professor. She is a co-founder of Urja Counseling and Training Indore. Also, ma'am is working as assistant professor in Prestige Institute of Management and Research Indore. Ma'am is also co-coordinator of IQSE at PIMR. As a research expert and trainer, ma'am has conducted many workshops and FDPs on SPSS module, research paper writing, and analysis through R programming. She has completed one research project related to the medical field, which has been presented before the Central Ministry. She has rich experience of more than 10 years in research, and with this, she has more than 42 research papers published in various Scopus national and international journals. She has also presented research papers in more than 20 conferences and won 5 Best Papers Award at JIMS Delhi, Pacific University Udaipur, and 3 in Prestige Indore. She has also guided more than 500 students in their major and minor research project. As an author, she is also written a book on curricle problem of our society along with a co-author titled as Atmatya Q. Now I would like to request ma'am to start the session.
Thank you so much, first of all, Saloni ma'am, for the warm welcome. Thank you for
Thank you, ma'am.
introducing me with the participants. So, good evening, everyone present over here on this virtual platform. I, Dr. Chanchala Jain, welcome you all in this 5 days FDP. Today, I'm going to discuss about the application part of SPSS in data analytics. So, firstly, I want to extend my gratitude towards the RFI, Ajay Jain sir, Saurabh Jain sir, and the entire RFI family for giving me a chance to interact with the participants who have joined this FDP around the India. So thank you so much, Ajay sir. Now I think without delaying, I'll start my session. Before starting the session, I think yesterday people have attended one session which was on, I think, descriptive and inferential statistics, right? So I think we will keep this session interactive. So before proceeding, because as today I'm going to tell you the application part of the SPSS, can anyone tell me what do you mean by descriptive statistics? I hope you are able to listen me properly. Saloni ma'am, am I audible clearly?
Yes, ma'am.
Fine, thank you ma'am. So friends, I think this is a learning platform. We all are here to learn.
Yes, ma'am. Descriptive statistics के बारे में आप पूछ रहे थे.
Yeah.
हाँ मैम, ये जो एग्जिस्टिंग जो डेटा होता है उसकी जो कैरेक्टरिस्टिक्स है उसको जो एक्सप्लेन करना होता है उसके अंदर डिस्क्रिप्टिव स्टैटिस्टिक्स का यूज किया जाता है.
Okay, fine. Can anyone boss
जी मैम.
Mike?
ओके मैम, थैंक
Yeah. So now I'll ask the next question. If I want to assess it, whatever is the data with having us, we can apply the descriptive statistics on that data. I hope he said to summarize the data, right? So can any one of you tell me what are the methods using that we can summarize the data?
मैम, फिर से रिपीट करना क्वेश्चन.
Sorry.
क्वेश्चन रिपीट करना मैम, क्या पूछ रहे हैं?
I asked which methods we need to use to describe the data under the descriptive statistics.
Yes ma'am. Central tendencies, mean, mode, median, dispersion, standard deviation, mean deviation, range और skewness वगैरह है. इनके द्वारा अब आप उसकी कैरेक्टरिस्टिक्स को फाइंड करके और उसका एक्सप्लेन कर सकते हैं, इंटरप्रिटेशन भी
Very
कर
good.
सकते हैं।
Very correct, sir. Thank you so much.
so much.
Sir, that we need to use the measures of central tendency, measures of dispersion, and measures of distribution to summarize the data. These all comes under the descriptive statistics. Now, can anyone tell me what are the methods we are using, or what do you mean by firstly the inferential statistics?
मैं दे सकता हूँ मैडम आंसर?
Obviously.
इन्फ्रेंशियल स्टैटिस्टिक्स के अंदर हम क्या करते हैं मैम, जो यूनिवर्स है वहां से सैंपल कलेक्ट करके और सैंपल के बेस पे यूनिवर्स की जो मेजर है उसको हम फाइंड करते हैं और जो हाइपोथेसिस वगैरह हमने बनाई है उसको जनरलाइज करने की कोशिश करते हैं।
Very good. Very good. Sir. I think you have all the knowledge.
जी मैम?
Yeah. So I Gors, yes, thank you so much. So I think Gors has given the correct answer. Whenever we are talking about statistics, usually the size of population is very large, right? So in that case, what we are doing, we are taking a sample from the population. And when we are drawing a sample from the population, using a sample, we want to conclude something about the population parameters. And that way we are using the inferential statistics. That is, for the hypothesis testing, we are using the inferential statistics, right? So give me a second, I'm going to share my screen. Okay, I have shared my screen and I hope the SPSS window is clearly visible to all. Any confirmations? I think you people need to give me answers after unmuting yourself, because I am now on the another screen. I shared my screen, so I cannot see anyone in a meeting. So you need to tell me whether my screen is visible or not. Anyone please confirm?
Visible, ma'am, visible.
Fine. So now, I think you can see, I think many of you have already worked also in SPSS, and if not, first time if you are looking at the interface of the SPSS, you can see when I'm showing you this interface, it is very much similar to the Excel, right? So, means in Excel also we are having the rows and columns, and the rows and column combination is known as cell, right? So the same type of display is there for the SPSS also, but the only difference is that you can see at the bottom left where I am rotating or hovering my mouse, you can find here there are only two views. Whereas when we talk about Excel, in Excel you can insert so many worksheets, right? But here it is not like that. Here there are two defined views available in SPSS, that is the data view and the variable view. Presently, the first button or first view is the data view, which is activated, right? Now, when I click on the variable view, you would be able to see this is the variable view. From the name itself, it is quite clear. Here we can define our variables, right? Under these parameters like name, type, width, decimals, label, values, missing, columns, alignment, and measure. So these are the parameters. On the basis of that, you need to define the name of your variable, right? So for example, if I'm writing the name of variable as gender, right? I have only written the name and now I'm pressing the tab key. So you can see many of the cells value are already filled by the SPSS, right? So that means according to SPSS, gender is a numeric variable. So by default, the type of variable will be numeric in SPSS because it's a quantitative software, right? So generally it takes a variable as numeric, but if you want to make any changes in the type, you can click on these three dots. And that way you can decide upon what should be the appropriate type of your variable. So according to your need, according to your collection of the data, you can set the type of the variable, right? Similarly, when I talk about width, so width generally we are using when we are having the what I can say string data, that is character data, right? When I need to write the address or name, something like that. In that case, we are using this particular width value. Otherwise, for numeric, there is no use. But if you are taking a numeric variable in decimal points, in that case, this width will play a role. Means it will allow you to insert a number of characters in a particular cell. Then decimals means decimal is, I think, quite obvious. If we are having a variable on a continuous scale, in that case, we can decide upon up to what decimal points you want to show your variable. Then label means if you want to detail the name of your variable, because usually we are keeping the name of variable very crisp and concise, very small, clear name we are giving to the variable, right? But if you want to elaborate properly what the variable is, you can use this label option. Then values here, as we know, as I think all of you are involved in the research, so you know this thing that to perform statistics on the data, we need to have the quantitative data, because statistics cannot deal with the qualitative data, right? So in that case, generally whatever data we will be having, we will give the code to the data, right? So for giving the code, whatever code, suppose you can see gender is a numeric, but usually we know gender is a qualitative variable, right? So generally we can ask for the gender of the respondents, like the person is male or female. So male and female are what? These are the qualitative terms. But for the analysis purpose, we can give some number to these categories. So that way, what is the number stating to us? You can come to this values option, and here you can type. Suppose you have written 1 for 1 is the value, and you have written 1 for suppose male, and then you have added it. Then 2 you have written for suppose female, right? And then you have added that, and that way you can click on OK. So now it is recorded in SPSS that if you are entering in this column 1, so 1 meaning is male and 2 meaning is female. Then the term or the next column is a missing value. So if suppose you want to keep something missing from your analysis, so here this option will allowing you to do so. You can click on these 3 dots, and that way, suppose I do not want to include the data of male, so I can write here 1, because we know 1 is male in my data. So when I'm defining this 1 and I'm pressing on OK, so that way it will be stored in the SPSS that if I will perform any analysis using the gender, so in that case SPSS will only include the 2, that is the female data, and it will not include the male data, right? So that way you can define your missing values. Column is nothing. Column and alignment are just for the what I can say, the beautification purpose, as we are using in the Excel or maybe in Word documents or something. So that way you can see when I'm coming here, and you need to see what I'm doing. I'm just stretching this particular column, and we can see its impact on its width, right? So that means up to 14 characters you can see at a time in a gender column, right? Up to us, by default the value is 8, right? So if you want to increase or decrease, that you can do using this up and down arrows. Coming to the alignment, for generally the numeric variable, it is very similar to Excel. If you are having the numeric data, alignment will be the right alignment. If you are having the character data or qualitative data, in that case alignment will be the left. But if you want to make changes in the alignment, that you can do using this. Coming to the next, this is the measurement scales. I think you people have studied these maybe yesterday, or if not, maybe you people are knowing that in statistics, or maybe when I talk about social sciences, generally there are some variables which we cannot measure directly, or we do not have any apparatus to measure them, right? Like satisfaction in a person. So I cannot measure satisfaction directly. So generally we are using these scales. So these are the measurement scales: nominal, ordinal, and the scale. Nominal is the first label that is helping you to categorize your data. Ordinal scale will help you to categorize your data. Along with that, you can order your categories. Scale means you can have the data means where you can categorize also, you can order also, and there will be the equal distance in the categories. So that way these are the scales. But usually in statistics there are 4 scales: nominal, ordinal, interval, and ratio. But when we talk about SPSS, SPSS is having only 3: nominal and ordinal, and last one is the scale. So that means if your variable is measured on interval scale or on ordinal or on ratio scale, you will define its type as scale. So this way we can define our variable in SPSS. Now coming to the data view, you can see whatever variable you will define there in the variable view, they will become your column headings like this. So first variable or one variable I defined there, this is becoming the column for my data. So here you can enter your data manually. If not, you can use the import option of the SPSS, and that way you can bring the data in the this particular environment of SPSS. So I think before proceeding to the next point, I need to ask you people whether this particular thing what I discussed is clear to you people or not.
Clear, ma'am, clear.
Fine.
Fine, ma'am.
Fine. Now I'll proceed to the next point, how to import data in SPSS, right? So for importing the data, you need to go to the file menu. I hope you people are noting down because maybe the speed is little fast, but if you want to note something, you can stop me and you can ask me that man, please keep your space slow. So I'll do that because we are having 1 hour and I need to discuss few more things, right? So now you need to go to the file menu. In the file menu, you need to go to the open and then you can select the data, right? Once you will click on this, the open data dialog box will appear in front of you. Here you can see you are having various files, but in the first option of first section, that is login. Here you need to give the location of your file. So you need to know where your file is situated in your desktop or in your laptop. That way, using this drop down, you can select the appropriate location from where you need to pick the data, right? After that, if your file type is suppose Excel, I'm doing this, I'm changing the files of type. Suppose it is Excel. So that way, in that location, if Excel file will be available, it will show you. So suppose I want to pick here the employee data, right? So that way you can click on this and you can press on open button. And once you will press on open, in few seconds you would be able to see your data, and that way it is showing you the preview of your data. But if suppose there are more than one worksheet in your Excel file, using this drop down arrow, you can select the specific sheet from where you want to pick the data. Or else, as you can see, I am having only a single sheet in my Excel. So that is why I can go with this particular sheet. This is the preview of your data. And then you can press on the OK button. And in few seconds, your data will be there on your screen or on your SPSS window. I hope the data is visible to everyone. It is the importing process of the data in SPSS. Is it okay?
Okay, ma'am, okay.
Fine. Now, moving further, just a minute. So I think rather than doing this, I have one more file that I'll open for you. Yes. So here the same file I have opened, but here the labels are defined properly, right? So these are the meaning of the variable. You can see this is gender, B date. So that way you can see properly in the label, the meanings or the elaboration or detail of the variable is given, right? Now, if I want to perform descriptive statistics in SPSS, what I need to do? So if you people are making your notes, you can write down the process. For applying the descriptive statistics, we need to go to the analyze menu. Then we can go to the descriptive statistics. And from here, we can select the descriptives. I hope it is clear. May I click?
Yes, ma'am, yes.
Now you can. We are having all the variables listed at the left hand side, right? So here, suppose for the current salary, I want to check the descriptive statistics. I want to check what is the mean salary, what is the standard deviation of the salary, something, right? So I need to select the variable, and using the arrow key, I can shift my variable into the right hand box, right? Now you can click on the options, and from options button you can find by default SPSS will give you the mean of the salary, standard deviation, minimum and maximum value. But if you want to check suppose kurtosis and skewness also, so you can click on those options. Apart from that, you want to check something some other things of your variable, that way these options are available and you can just check these boxes and then you can press on continue button, and then you can press on OK button to generate the output. So here will be the one more window, that is the output viewer window. In this window, you would be able to see the output of the descriptive statistics, right? I hope my output window is visible.
Yes, ma'am.
Okay. Now you can. Here I am having a current salary variable, and statistic meaning is how many observations are there in my data. So it is showing me 474 observations are there for the current salary, right? Minimum of the current salary is 15,750. Maximum of the current salary is 1,35,000. Mean statistics meaning is the mean salary or mean current salary is 34,419. Then standard deviation is 17,075.661. Skewness figure is 2.125 and kurtosis figure is 5.378. So usually looking at skewness and kurtosis, we can interpret these figures are very high level or the high in magnitude, or these figures are very large. That way you can see or communicate this thing or interpret this thing that your current salary is not normally distributed, because the skewness value is very high. It is 2.125 and the kurtosis is also again the very high, although both the figures are positive. So you can see this thing or you can communicate this thing that the skewness is positive, sorry, salary is positively skewed, and kurtosis is telling you that your salary is leptokurtic, right? So I hope you have studied this thing yesterday. Moving ahead, talking about the other way of checking the descriptive statistics for your data. For that, you need to again go to the analyze, then you can go to the descriptive statistics, and this time you can select the next option, that is explore. Once you will click on this, the explore window button will open, right? So from here, you need to shift the current salary into the right hand box, that is the dependent list. So this is your dependent variable here, right? But if suppose you are having one independent variable also, for example, gender, right? So you can shift this into the factor list box. Then you can click on the statistics, although there you do not need to select anything. We will go with the by default setting of the SPSS. We will get the descriptive statistics, and here the confidence level interval of mean will be 95%. Then using the plots, as salary is a continuous scale variable, right? It's a ratio scale variable. So if suppose I want to check its histogram, I am deselecting the stem and leaf, as stem and leaf is now little older method. So we'll go with the histogram. And one more thing you can check here, that is the normality plots with test, and then you can press on continue. Then you can press on OK. You would be able to see your output in the output viewer window. So I hope my output is visible to everyone. Any confirmations?
Yes, ma'am. Visible.
Okay. So here you can current salary in context
Visible,
to the
ma'am.
gender I'm talking about. So we can see that total 216 are the females in the data and total 258 are the males, right? There is no missing value in the data, right? So that way we can say this is the data we are having for the male and female for the current salary. Going to the descriptive statistics. So now you can see the difference. Previously, we have got the everything, that is the measures of central tendency, measures of dispersion, and the measures of distribution, all for the current salary, right? But here there are two things. Here we are getting all these things, but according to the gender, that is according to the female and the male, right? So now you can see here for mean, if I want to find the current salary, it is 26,031. Similarly, for the male, this is 41,441. Similarly, if I talk about confidence interval for mean, so this is the range of confidence interval for mean for the male, female category, and this is for the male category. Median you can find, which is 24,000 something for the female, and here it is 32,000 something. One more thing I left, that is the 5% trimmed mean. 5% trimmed mean meaning is, if suppose there is any outlier available in your data, so if you can remove, means SPSS has removed 5% outliers from both of these sides, upper side and lower side, and that way this would be the mean after removing the outliers, right? Standard deviation and variance is given in the next rows. Minimum of the salary and the maximum of the salary for female and male both are given there in the respective sections. Range of the salary is range. I think everyone of us know this thing, that range is what? It is the maximum minus the minimum, right? It is the interquartile range, which is the difference of third quartile and the first quartile. Skewness and the kurtosis for the male and the female both are given here, right? Now next one is the normality testing. So usually when we are performing statistical test, generally we need to ascertain this thing, that whether the variable is normally distributed or not. So here you can see current salary is normally distributed or not for female and male category. You can find we need to apply or report the results of chaperone. That is the last section, right? Here significant value is 0.000 for both the variables. So I think, can anyone tell me if significant value, that is the p value, is less than 0.05? So what we will conclude? Anyone? Yes.
Yes. Ma'am, please repeat the question.
I said significant. I think you people are aware about the concept of p value, right?
Yes, ma'am.
Yes. So this is the significant value. This is the last column here. So I'm asking if significant value, that is p value, is less than 0.05. In that case, what we will conclude?
Ma'am, we will accept the null hypothesis then.
We will, no ma'am, we will reject the null
Yeah,
hypothesis.
sorry, reject. Yes, ma'am, reject. We will found significant and we will reject.
Yes.
Yes.
So when
Yes, yes.
so when
So when the P
is
less than 0.5,
in that
in that case,
I think, ma'am, you need to switch off your mic. You need to close your mic. Yeah. So when the p value is less than 0.05, we are going to reject the null hypothesis. But question comes, what is the null hypothesis, right? So if you are making your notes, you can note down this thing. For the Shapiro-Wilks test, the null hypothesis will be the variable is following normal distribution, or you can say variable is normally distributed. And according to our output of the test of normality, we are rejecting the null hypothesis. That means we can conclude that the salary is not normally distributed for female and male, both the categories. I hope it is clear.
Yes, ma'am.
yes, ma'am. Yes.
Talking about a histogram, you can see for both the categories, female and male, we are getting the two histograms, right? So you can see when I talk about the histogram for the female, so this is the salary distribution of the female employees, right? So that way you can see it is quite clear that the salary is positively skewed, right? Because at the left hand side we can find there are so many bars are coming and they are small in size, right? So that way we can say, or we can conclude this thing, that there are very less number of females who are drawing the higher salary, right? And because this is the frequency count and these are the salary figures, that way we can say that there are very less number of females who are getting a good salary or handsome salary, right? And this is a positively skewed data for the female. Going down and talking about the male salary, here again the scenario is same. As you can find that salary is high. When the salary is high, we can find there are so many, or where there are very less number of people or male which are drawing a higher salary, right? So again, this graph is telling you that your data is positively skewed data, right? QQ plot generally indicates the normality of the data when your data points, means these are the data points available in the data, these are the observations of your data. So if these observations are following this fitted line, in that case you can conclude your variable is normally distributed. But again you can see these are not following exactly the line, there is deviation from the line, right? So that means the data is positively skewed. Again, for the male category, we can find the similar thing. These points are not exactly following the this fitted line. That way, again, you can conclude that your male's salary is not normally distributed. Generally, detrended normal QQ plot, we do not need to report. We can skip this. We can come down to the last graph. This is the box plot. Box plot generally we are using to ascertain the outliers in the data, whether there are certain outliers in the data or not. So I think, can anyone tell me what do you mean by outliers?
Extreme values.
Extreme
value.
Very correct.
Very correct.
Means there will be certain observations or figures which are not matching to your remaining data points, right? They are very far from your remaining data points. So that way there is a chance, means there is a chance, that means they will definitely impact your results. One thing once you will get the mean or something, these large values will impact your mean figures, right? And if mean is affected, it is quite obvious standard deviation and variance will also be affected, because for calculating standard deviation and variance, etc., we need to take the help of mean. So that way you need to ascertain this thing if outliers are available in the data, whether you want to keep them in your data or whether you want to discard them. If you want to discard, you can discard them, and then again you can perform all these things which I have just performed, and then again you can check the normality of your value. So this way, this is the descriptive statistics. Now I will move to the inferential statistics, right? So before moving to the inferential statistics, suppose I'll show you my data again. Just a minute. So here I am having the salary. This is our current salary, suppose, and then talking about this is the gender. So suppose I want to compare the salary of male and female, right? So can anyone tell me, firstly, which will be the appropriate test here?
Ma'am, t-test.
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 Okay. Ma'am, in
T-test.
Yes.
Yes.
I think there
I
are
think there are
some
some things to test.
So which
Which
t-test?
t-test? Independent sample t-test.
Independent samples t-test. Very correct. So we will go for here the independent samples t-test. So ma'am, can you tell me how many variables are required to perform independent samples t-test?
Ma'am, 30.
No, I'm asking number of, not observations. I'm talking variables. Which type of variables and how many variables are required?
Ma'am, here two constructs, male and female, will be there.
Hmm. So means we need to have two variables. This is what you are saying?
Ma'am, a metric variable and the group variables will be two.
We need to have a metric
One metric variable and two non-metric, that is group variable.
Okay. We need to have the one metric variable and one
two non-metric, that is the group of female and
to have
male.
only one categorical, ma'am.
One category. Yes, we will divide it
variable.
in yes, male and female.
Variable with two categories or two groups. Right? So this is the basic requirement of the independent samples t-test. We need to have one metric variable, that is numeric variable, and we need to have one non-metric variable, that is categorical or qualitative variable, with the two groups or categories or labels, right? So that way we can perform independent samples t-test. So now can any one of you tell me what will be the hypothesis here?
There does not exist any significant difference between the state variable between.
Sorry?
There does not exist any significant difference in the metric variable between the two groups, that is two select groups.
Okay, fine, ma'am. There is no significant difference in the mean.
Yes,
in
the mean of the metric variable.
Right?
Yes.
This will be the null hypothesis. So suppose this is my null hypothesis. Now I want to check this hypothesis using the data I have just shown you. So now I'll move to the data and we will see how we can perform independent samples t-test in SPSS. For the purpose, we need to go to the analyze menu. Then you can go to the compare means, and then you can select the independent samples t-test, right? Then you can click on this. So the box will open. Here you need to pass your current salary into the test variable box. Test variable box is requiring for the metric variable or numeric variable or continuous variable. And then the categorical variable or non-metric variable you will shift in the grouping variable box. So once I have shifted here, you can see this define groups button is activated now. It is asking us to define the groups, because in the generator you can find there are two question marks, right? I need to click on this and here I need to write. So I think in my data, first group is male. I need to check this term. I need to check this. So how I can check this? For checking this, you need to go to the variable view. Here I can find yes. So the female stands for F and male stands for M, right? So again, I'll go to the analyze, compare means, and then independent sample status, shifting my current salary to the test variables box and shifting my gender variable into the grouping variable box, right? Now clicking on the define. Okay, now here I clicking on the define, and here I am writing, suppose my first group is of the female and second group is of the male, and then I can press on continue, and then I need to I need to do here after this only after defining the variable I can directly click on the OK to get the output, right? So I'm just clicking on OK, and you can see, right? I hope you would be able to see the output window. In output window we can find the first section is talking about the descriptive statistics, which we have already seen, right? Now coming to the independent sample t-test window or the output. Now here you can find the first section is talking about the Leven's test of equality for equality of variances. So you need to check whether the variance is equal or not. So now you can check the F and its significant value. So the significant value of F test is less than 0.05. So I think we know if it is less than 0.05, we need to reject the null hypothesis. That means we are concluding this thing that the variance is not equal, right? Clear? I hope it is clear.
Ma'am, in Levin's test, it should be more significant value.
Yeah. If it is more, then you will conclude that variance is equal. Otherwise, you will conclude variance is not equal.
That is the assumption. Yes, ma'am.
Yes, right. So that means here our p-value is less than 0.05. So we need to reject the null hypothesis of Levin's, and we'll conclude that variance is not equal. That means there is a significant difference is existing in the variance, right? So that way you can find there are two rows: equal variance is assumed, equal variance is not assumed. So we are assuming there is no equal variance. So we will go in the second row and we will report this t-value, second t-value, and its respective degrees of freedom. And its respective significant value again says that the p-value is less than 0.05 for the t-test. That means now the t-test hypothesis, that is null hypothesis, you are going to reject. So if you are rejecting the hypothesis of the t-test, I think you can see we have written this hypothesis here. So what we can conclude here? That means there is a significant difference in the mean salary of male and female employees, right? I hope people are understanding this.
Hello.
Yes.
Actually, in Levin's test, we assume equality of variance, that variance of these two categories, male and female, are equal. That is our
Variance
assumption.
of salary should be equal in male category and female category.
Yes, that is our assumption. And p value is 0.00. That is, we reject the assumption,
Null
right?
hypothesis. Yes, we are not, means our data is not following the assumption.
Okay.
Fine. So now you can see we need to go in the second row and we are reporting these, and we are again rejecting the hypothesis of the t-test. So that way we can conclude that there is a significant difference in the mean salary of male and female employees. I hope it is clear.
Ma'am, if Levin's test p-value is less than 0.05, so how we will proceed with t-test results?
Ma'am, it will be totally depending upon a researcher, because you need to answer the questions of the reviewers. Usually in some of the literature review, you can find t-test is robust for these things. If not, you can go for the non-parametric test. If you are not okay with this, you can go for non-parametric.
Okay. Okay, ma'am.
Okay. Similarly, I'll go to the analyze window again. Oh, sorry, analyze tab again. Now, again, just a minute. We'll go for firstly looking at the data. Now you can see in my data, we are having a salary. Now I want to compare the salary on the basis of job category. And you can find in job category, there are 1, 1, 1, 1, 3, and 2. Means 3 labels available. We'll come here and see the labels. We can find these labels are what? Here 1 for clerical, 2 for custodial, 3 for manager. So now if I want to compare the salary on the basis of the job category, which test I need to opt for?
ANOVA.
Why, sir? What is the reason why we will go for ANOVA?
We go for ANOVA if the group is more than 2.
Correct. So means the ANOVA, that is, I'm talking about one-way ANOVA here, right? So one-way ANOVA is again very similar to the independent sample t-test. Independent sample t-test also does the main difference in the categories. One-way ANOVA also do the same and does the same, but the difference is in case of independent sample t-test, we will be having only 2 groups or 2 categories. But when we are having more than 2 groups or categories in the categorical variable or in the what I can say qualitative variable or non-metric variable, in that case we will go for the one-way ANOVA. Working is same, means t-test will also find the mean difference, ANOVA will also find the mean difference, right? So this is your non-metric variable and salary will be your metric or quantitative or numeric variable, right? Fine. With usually more than 2 categories, right? Here we are having how many? We are having total 3 labels or 3 groups. We have just checked in the data. So that means here the appropriate one is the one-way ANOVA. Now what will be the hypothesis? There is no significant difference in the mean salary on the basis of job category. Fine. Is it okay? Confirmation, please.
Yes.
Fine. Now you need to go to the data. You can go to the analyze. From the compare means section itself, you can find the one-way ANOVA here, right? So in the same segment, you can find one-way ANOVA where the independent sample t-test available. You can click on this. Now you need to shift your numeric variable or metric variable in the dependent list and the second variable, that is employment category, in the factor list, right? Now you need to although do nothing here except clicking on OK, but still I'll click on options. And suppose I want to get the descriptive statistics and homogeneity of variances. I need to check these assumptions. Suppose I can click on continue and then I can click on OK. So you would be able to see output in the output window. This output is saying the first table is the descriptive statistics. For all the 3 categories, you can find how many of the employees belonging to these categories, what are their mean salary, what are the standard deviation of the salaries, and likewise. Further, talking about homogeneity of variances. So usually we can check homogeneity of variances on the basis of mean, right? As the current salary is the numeric variable, right? So here you can find the significant value is 0.000, which is less than 0.05. So again, you can say that current salary is not following the homogeneity of variances, right? Going down, talking about the ANOVA. ANOVA significant value is again less than 0.05. That means we are not going to accept the null hypothesis. So we can conclude that there is a significant difference in the mean salary on the basis of job category, right? Is it okay?
Yes.
So this is the one-way ANOVA. Coming to the data set. Now, if suppose I'm having these 2 variables, salary and salary at the beginning, so can I do or can I find something using these 2 variables? And if yes, what I can do? Can anyone suggest?
Correlation.
Okay. Okay,
Okay,
very
very
good.
good.
Sorry.
Sorry.
So we are having salary and we are having the salary at the beginning. This is your current salary, right? And as ma'am said, we will go for correlation here because there is a quite chance because that the current salary and the beginning salary are correlated to each other. So for correlation, we need to have the numeric variables or metric variables. So both the variables are numeric here, right? First thing, to perform Pearson's coefficient of correlation, right? Now, how to perform that? I'll come to the data. Here, what you need to do, you need to go to the graph, you need to go to the analyze. You can click on the correlate and then you can click on the bivariate. Done. Then you need to shift your variables, both the scale variable and shifting in the variables box. And then you do not need to do nothing. You need to only press on the OK button, right? And you would be able to see your output. I hope output is visible. Output is visible, I hope.
Recording in progress.
Anyone, please confirm me.
Visible, ma'am.
Yeah. You can find here, if I talk about current salary and beginning salary. So in these two variables, the correlation value is 0.880, right? Now you can find there are double asterisk sign. So these double asterisk signs are saying you that this correlation is significant at 1% level of significance, right? So that way I can say that there is a positive correlation between the beginning salary and the current salary, right? And there is a 88% correlation between these two variables. 0.88 meaning is 88% correlation. Fine. And this correlation is significant and this is a positive correlation. That means if the beginning salary will be high, current salary is, but obviously will be high. Clear?
Yes.
I think using this data, we can perform regression as well. So for that, you can go to the regression and you can select the linear. And then I think, just a minute. And I think we know this thing when we talk about this, these two variables. So current salary will be the dependent and the beginning salary will be the independent. Although there are many other things according to your need you can click on, but I'm only clicking on the OK to generate the output. And that way you can see a simple output we are getting. And this is indicating you firstly the R value, that is the correlation value. Then it is showing you the R square. R square is very important in case of regression. This indicates the variance explained by independent variable, independent variable. So we can find 77.5% variance in current salary is explained by beginning salary, right? ANOVA table is coming in case of regression, which is helping you to ascertain this thing that your variable is, or sorry, your model is a good fit or not. So the significant value says it is less than 0.05. So we can conclude this thing that variable or the model is the good fit model, right? Now you need to see, I think we know generally for regression, as we say that we are fitting a model, right? So in that case, we can call it as y equals to a plus bx, right or not?
Yes.
So here it will be a current salary, which is equals to a plus b into beginning salary, right? So now we need to find the values of A and B only. So you can find the value of A will be 1928.206. So here I can write 1928.26 will be the value of A, and the B value is 1.909 multiplied by that. Fine.
Yes, ma'am. Plus error in the last.
Error term can also come here.
Yes.
Usually we are keeping the error term like this, right? Fine.
Yes, ma'am. Yes.
So this way you can predict your current salary when you are knowing the beginning salary of any employee. This is known as the forecasting using the regression. This is a simple linear regression, right? I hope it is okay.
Yes.
Similarly, if you want to perform some types of graphs or something, you can go to this graphs. You can use this chart builder. Using the chart builder, suppose I want to go for pi is there. Yes, suppose pi. So I can drag this in this particular preview area. I can shift suppose gender here on this slice pi, and then I can press on OK. So this way it will generate the pi for me. So that means few or type of graphs also you can make using the SPSS, right? So I think this is what you can do. Otherwise, there are some other options available. If you want to do the transformation of your data, you can use this transform option available here. You can record your data. So that way, with the practice, I think you can explore. There are so many options available in this SPSS, which can help you out to analyze your data well. So I think this is all from my side for a day. If you are having any queries, you want to ask me anything regarding this, you can ask. Yes.
Ma'am,
Any
ma'am, in case of ANOVA, we should also report post hoc test results.
obviously, ma'am, you can go for that when your ANOVA value is coming significant. Means when you are concluding that there is a significant difference. In that case, you can go for the post hoc test also
Okay.
for multiple comparisons. Anything else? No other questions? Yes.
Hello,
Yes.
ma'am. If we want to compare in this example, only the average difference in salary of three categories, then we use ANOVA, right? And if I want to compare average difference in the average salary of three categories employee, but only in male, then is it possible?
Only?
Only in male.
I'm not getting it.
Okay, the ANOVA was we compared whether average salary is different or not in three category of employees, right? But I want to compare average salary is different in three category of male employee only, removing the female employee in these three categories. Is it possible?
Sir, I think in that case you need to understand how you will segregate the male. Are you segregating male on the basis of their age groups or something? So you need to have that parameter. If that parameter is available, you can go for. Or maybe if male employees belonging to various different types of that I can say designation basis. That way you can do that.
Yeah, here we have three designation, and what we have done is overall comparison of employees in these three designations with ANOVA.
Are you not
But,
getting me? What I'm telling you, that you want to compare the
yes.
salary of the male, but you need to have some base for that. For example, you can have the base of resignation. In that case, in those that these three different designations, you can compare the salary. On the
Yes.
basis of male, how you can compare, sir? Comparison should be on the basis of something. If only
I
male
want
is
to
there,
compare.
how you can compare to me?
See,
So
my
that way I
question
am telling
is,
you, you need to take some base.
I want to compare average salary of employees in these three category. Then, as you explained, we have to use ANOVA, right?
Right.
Now, I want to compare difference in average salary of these three category of employees, but I want to take only male employee,
Obviously,
not the
it is
female
quite
employee.
possible.
Then is it
No
possible?
problem. Sir, possible, quite possible, because base will be the designation. No, that is what I am telling you.
Okay.
In that case, you need
Right.
to bifurcate your data firstly, and that way you
Okay.
can do it.
All right. So with the same SPSS window, it will be done.
Yes.
All right. Okay. Thank you.
Okay, sir. Any other question?
Ma'am, if we are having more than one dependent variable,
In
then
that
which
case,
is
you need to go for MANOVA.
okay, maneuver. Okay. Thank you.
Thank you, ma'am.
Thank you, madam.
Thank you so much, sir. Any other question? Yes. I'm waiting. Any other questions you are having? No? So is it possible for us to capture a pic? Can you people switch on your cameras? And then we will hand over the session to the Saloni ma'am to wind up it.
Yeah. ಎಲ್ಲರೂ
I can I can see 3 people now. Palima ma'am, Avinash sir, and Yashish sir. Amrita ma'am as well. Give me a second, I'm just capturing. I think one more person I can see, it is Tarun Sharma sir. Yes, I captured. Thank you everyone. I captured. Thank you so much.
hello ma'am.
Yes, ma'am.
Hello.
Thank you,
Ma'am,
ma'am.
is it possible if we get some study materials on these tests and all? It will be helpful for us for research studies as we are pressured.
I think when we are talking about the full-fledged workshop of SPSS, generally we can provide ma'am that. For a particular session, I think it is little difficult for me to make everything and provide you. But I'll
because
try.
it will be very helpful, ma'am, if we get.
Yeah, I can understand how obviously for a newcomer it is very, very important thing.
Yeah.
Yes. Or else you can means YouTube channel is also available of mine. If you want to explore that, there you can find these things or the explanation of these things. But still might be possible in some other FDP we'll meet and definitely will provide you something. But still for this session I'll try.
Please.
Yeah.
Ma'am, your YouTube channel is of which name? From which name?
Dr. Chanchal Jain.
Okay, thank you, ma'am.
Yeah. So I hope
Thank
it
you,
is
ma'am.
okay. Yeah, thank you so much, Amrita ma'am.
Yeah, thanks.
Yes. No more questions. Can we hand over the session to Saloni ma'am?
Yeah, ma'am.
Okay. Saloni ma'am, over to you. We are done.
Okay, thank you so much, ma'am, for your valuable knowledge and your precious inputs. And also thanks to all the participants for attending this faculty development program and staying with us. On this note, I would like to end this session. Have a great day ahead.
Thank you
Thank
so
you.
much, Saloni ma'am. Thank you, everyone. Thank you, Ajay sir. All the
Thank you, ma'am.
participants, thank you so much for sparing your time. Thank you.
मैडम
Thank you so
पार्टिसिपेंट
much.
का कोई अगर ग्रुप बना है तो लिंक शेयर कीजिए प्लीज।
Sorry.
पार्टिसिपेंट का कोई ग्रुप बना है तो लिंक शेयर कीजिए मैडम, ऐड नहीं है हम।
I think for that, Yogra sir, anyone from RFI can add you, sir. I think
Sir, link is there in the mail.
Yes, sir. Link is in the mail. You can connect from there.
Saloni ma'am, may I leave?
Yeah, ma'am. Sure, ma'am. Thank you so
Thank
much,
you.
ma'am.
Thank you so much. Thank you, everyone. Have a good day. Happy
Thank you.
learning. Good night from my side. Take care.
Take care, ma'am.
Thank you.